Artificial intelligence uses the cloud to acquire data and knowledge, which of course had to be uploaded first. Therefore, the final result is certainly strongly dependent on the willingness of people to upload data and the accuracy of it. Nevertheless, the current and potential impact of artificial intelligence in many industries is staggering. Some of the world's largest companies are already using it with impressive results. The potential applications are wide, ranging from materials design and synthesis to experimental design, production design, but also failure analysis and even waste reduction and more. The potential impact on the development of batteries should not be underestimated. The technology can browse through millions of records to describe the relationship between measured data and battery parameters. Manufacturers can test millions of combinations of electrolytes, anodes, and cathodes at any given time. Thus, by combining innovative data science powered by artificial intelligence with expertise in electrochemistry, cell structure, anode, cathodes, and electrolytes, much more complex conclusions can be drawn. How then does that work? So we will give you an example that is relevant for the understanding. The proposed method concerns combinatorial chemistry. Combinatorial chemistry involves chemical synthesis methods of preparing a large number of components in one single process. The example here shows the synthesis and characterization of battery materials to find out which composition provides the best material. By selecting the one that performs best agrees with what we have seen as machine learning. If we, on the other hand, understand what the underlying reasons are via, for instance, a model, we can put that information in the cloud and let artificial intelligence evaluate the best material, which may even lead somewhere in between. Here we are using materials made via exactly the same procedure. Comparing materials synthesized via the same method, we most likely have to use a similar approach as shown earlier by averaging the outcome of all materials found in the cloud. This we have to learn artificial intelligence to do so. It becomes even more complex once these materials are made via another synthesis method. But since there is so much information available in the cloud, it would be interesting to figure out how we can use artificial intelligence to evaluate that. This could even lead to an optimal synthesis process. A very nice task for people who are interested in artificial intelligence for optimizing battery materials. This approach may not be solely important for the synthesis of an optimal material, but also can be used for optimizing the cell assembly and more. You see, there is certainly a huge open field in battery research for artificial intelligence. In R&D facilities, battery chargers collect massive amount of data from batteries in a short period of time, including performance data such as cell temperature, real-time resistance, operating voltage window, charge and discharge current, and swelling levels. This creates mega to terabytes of data from thousands of batteries, which means that an endless collection of data is created. Analysis using traditional statistical or manual methods is extremely challenging. Artificial intelligence can assess information and construct a mathematical model at a much faster rate than we can do. Systems can learn and improve automatically through experience without being explicitly programmed, provided that the information has been uploaded. This will also allow us to gain a better understanding of existing batteries. The ability To quickly test all kinds of combinations means that the development of the materials and their processes to make the battery cell is much faster. This drastically reduces the number of experiments required, dramatically shortens development time, and thereby significantly reduces development costs. One intriguing application is to implement artificial intelligence into electric vehicles, operational software, where it would continuously monitor battery health and performance and set back data for product improvement. In addition, by creating smarter batteries with built-in sensing capabilities and with self-healing functionalities, the battery management system can be aware of their state of health and even rejuvenate battery cells or modules when needed. Artificial intelligence also allows for faster developments and the ability to overcome problems that might not be solved otherwise. For the applications of electric vehicles, this is of enormous importance in relation to increasing the driving range. This particular case is part of another MOOC provided by the TU Delft.